Critical requirements. Six Sigma projects can be directed at a number of CTX or critical to X requirements as given below. Critical to quality, CTQ. Cost of quality, COQ. Critical to delivery, CTD. Critical to price, CTP. Critical to safety, CTS. Let us look at a few examples for each of the CTX requirements. Critical to quality, CTQ. Critical to quality improvement projects may include simplifying product designs, aligning product designs with customer requirements, meeting current marketplace quality levels, exceeding current marketplace quality levels, exceeding reliability and maintainability requirements, exceeding product appearance expectations, meeting technical requirements, providing products that are more durable. Cost of quality, or COQ. Cost of quality improvement projects may include reducing internal rejections, reducing external rejections, minimizing salvage and sorting operations, reducing warranty claims, reducing product variation, reducing process variation, reducing various forms of waste, eliminating unnecessary inspections. Critical to delivery, CTD. Critical to delivery improvement projects may include providing exact amounts of product, providing service within a specific time interval, ensuring immediate responses to customer questions, providing a product or service on the proper day and time, providing more rapid field service, providing cost-effective delivery methods, meeting customer packaging requirements, minimizing shipping damage. Critical to price, CTP. Critical to process improvement projects may include designing products that are easier to assemble, minimizing changeover times, reducing in-process inventories, minimizing product touch times, optimizing work cell design, streamlining internal workflows, reducing process flow variation, enhancing process velocity, eliminating redundant operations, maximizing product yields, speeding up operations, reducing cycle times, minimizing equipment downtime, maximizing preventative maintenance, performing value stream mapping. Critical to safety, or CTS. Critical to safety improvements may include simplifying tasks, mistake-proofing operations, providing operator visual prompts, providing safety cutoff devices, using warning alarms, providing adequate employee training, providing clear written instructions, protecting both operators and equipment from damage, making products that are user-friendly, providing constraints to prevent incorrect product use, providing backup redundancies for critical processes, conducting safety reviews, expanding prototype testing, providing protective devices when applicable, eliminating failure-prone elements, meeting product disposal requirements. Critical to quality characteristics, benchmarking. A process-focused business constantly realigns processes to remain capable of meeting changing market demands. Only by gaining predictability can an enterprise truly maintain capable processes to changing customer demands. Three key terms that help us define process capability are process baseline. Process baseline is the average long-term performance level of a process when all the input variables in the process are running in an unconstrained fashion. Process entitlement. Process entitlement is the best-case short-term performance level of a process when all the input variables in the process are centered and in control. Process benchmark. Process benchmark is the performance level of the process deemed by comparison to the best process possible. It takes us to the best that anyone has ever done. In practical terms, this means researching and finding the best that has ever been done in the industry. Six Sigma facilitates in understanding variation in our business processes. The fundamentals of Six Sigma. Cost of poor quality, COPQ. Traditional cost concept. Most companies utilize financial reports which compare actual costs with budgeted costs. The difference is called a variance, and if significant, may prompt management action. Departmental budgets may also be established with the results reported on a monthly or quarterly basis. These costs are necessary to carry out the functions of each department, including the control of product and process quality. The responsibility for financial control usually rests at the department or plant level. Until the 1950s, few, if any, companies focused any attention on the costs of poor quality. These results were hidden among various labor, material, and miscellaneous expense categories. Only the most obvious quality department charges were identified. Origin of quality cost measurements. In the 1950s and 1960s, some enlightened companies began to evaluate and report quality costs for the following reasons. Products became increasingly more complex. The customer expectations of products became more sophisticated. Customers demanded service after the sale and expected failure remedy. Both supplier and customer costs expanded due to labor and maintenance. Technical specialists were added to make improvements. The management alternatives needed to be in monetary terms. What resulted was a method of defining and measuring quality costs and reporting them on a regular basis, either monthly or quarterly. The quality cost reports became a vehicle to determine the status of cost control efforts and identify opportunities for reducing costs by systematic improvements. Since the cost of poor quality is high, some authorities say 15 to 25% of the total cost of sales, the opportunity for improvement should easily capture the attention of management and Six Sigma improvement teams. If a company has historically reported the cost of poor quality, then identifying improvement projects with a meaningful business return should be easy. If not, an improvement team, with the help of accounting, may need to accumulate pertinent data. The costs of poor quality, or COPQ, are those costs associated with providing poor quality products or services. There are 4 categories of costs. Internal failure costs. These are costs associated with defects found before the customer receives the product or service. External failure costs. These are costs associated with defects found after the customer receives the product or service. Appraisal costs. These are costs incurred to determine the degree of conformance to quality requirements. And prevention costs. These are costs incurred to keep failure and appraisal costs to a minimum. As you see in the pyramid, the failure costs contribute major expenses, whereas appraisal costs is a second level when compared for expenses. Prevention costs have the least expenses. Prevention costs. The costs of activities specifically designed to prevent poor quality in products or services. The following checklists indicate elements that may be included in the 4 major cost categories: applicant screening, capability studies, controlled storage, design reviews, education of quality or SPC, equipment maintenance, equipment repair, field testing, fixture design and fabrication, forecasting, housekeeping, job descriptions, market analysis, personnel reviews, pilot projects, planning, procedure reviews, procedure writing, prototype testing, quality design, safety reviews, surveys, time and motion studies, training, vendor evaluation, and vendor surveys. Appraisal costs. The costs associated with measuring, evaluating, or auditing products or services to ensure conformance to quality standards and performance requirements. These include audits, document checking, drawing checking, equipment calibration, final inspection, in-process inspection, inspection and test reporting, laboratory testing, other expense reviews, personnel testing, procedure checking, prototype inspection, receiving inspection, shipping inspection, test equipment maintenance. Failure costs. The costs resulting from products or services not conforming to requirements or customer user needs. That is, the costs resulting from poor quality. Failure costs are divided into internal and external failure cost categories. Internal failure costs are failure costs which occur prior to delivery or shipping of the product, or the furnishing of a service to the customer. External failure costs are failure costs which occur after a shipment of the product, or during or after furnishing a service to the customer. These include accidents, accounting error corrections, design changes, employee turnover, engineering changes, equipment downtime, excess interest expense, excess inventory, excess material handling, excess travel expense, failure reviews, late time cards, obsolescence, overpayments, premium freight, redesign, reinspection, repair and retesting, retyping letters, rework, scrap, and sorting. External failure costs. Note that many of the costs related to internal failure also appear on this list. Bad debts, overpayments, customer complaint visits penalties, customer dissatisfaction, premium freight, engineering change notices price concessions, equipment downtime, pricing errors, excess installation costs recalls, excess interest expense, redesign, excess inventory, reinspection, excess material handling, repair costs, excess travel expense, restocking costs, failure reviews, retesting, field service training costs, liability suits, rework, liability, scrap, loss of market share, sorting, obsolescence or design changes, warranty expenses. Optimum quality costs. Some authorities contend that every dollar spent on prevention will save approximately $7 in failure costs. Whether this figure can be defended or not, most companies initially find that they spend an inadequate amount on prevention activities. Initially, managers discover that prevention costs are too low and both internal and external failure costs are too high. Often, failure costs will exceed the appraisal costs as well. Even the relationship between internal and external failure costs may point to needed changes in planning or product design. The interrelationship of quality cost categories varies widely depending on the nature of product lines and processes utilized by a company. In this arena, there are few absolutes. However, listed below are some typical ratios for American companies. Note that there is considerable overlap between the category ranges. As per the table, prevention costs range from 0 to 5%, whereas appraisal costs range from 10 to 50%. Internal failure and external failure costs, that is both, range from 20 to 40% of overall costs. The implementation of preventative measures to control quality often takes a great deal of time. Appraisal measures are initially undertaken which cause internal failures to increase, but external failures, and therefore total failures, to decrease. Quality cost improvement sequence. Define the company quality goals and objectives. The relative position desired among competitors. The type of long-term quality reputation desired. Translate the quality goals into quality requirements. Outgoing quality levels required. Specific types of controls required. Special tests required. Estimate capabilities. Estimate capabilities of current processes, machines, systems, etc. Develop realistic programs and projects. Develop realistic programs and projects consistent with the company's goals. Determine the resource requirements. Determine the resource requirements for approved programs and projects. Set up quality cost categories. Set up quality cost categories of prevention, appraisal, and failure. Arrange for accounting. Arrange for accounting to collect and present quality costs. Ensure accurate figures. Ensure accurate figures or reasonable estimates by category. Analyze the quality cost data. Analyze the quality cost data for major improvement candidates. Utilize the Pareto principle. Utilize the Pareto principle to isolate specific vital areas for investigation. Quality cost comparison bases. Quality costs should be related to as many different volume bases as practical. 2 or 3 comparisons are normal. The bases selected vary depending upon product, company, etc. Some examples are labor bases, total direct labor, that is what's worked, and standard labor, that is what's planned. Manufacturing cost bases, shop cost of output, direct labor, direct material, and indirect costs. Manufacturing cost of output, including the total shop cost of output, that is above or plus, production engineering costs and expenses, provision for complaints, packing and shipping. Sales bases, net sales billed, contributed value, that is net sales minus direct material. Unit bases, quality costs, dollars per unit of production, quality costs related to production. Quality costs are normally summarized monthly on a report form. Typical quality cost report, advantages of a quality cost system, provides a manageable entity and a single overview of quality, aligns quality and company goals, provides a problem prioritization system and a means of measuring change, provides a way to distribute controllable quality costs for maximum profit, improves the effective use of resources, provides emphasis for doing the job right every time, helps to establish new product processes. Limitations of a quality cost system. Quality cost measurement does not solve quality problems. Quality cost reports do not suggest specific actions. Quality costs are susceptible to short-term mismanagement. It is often difficult to match effort and accomplishments. Important costs may be omitted from quality cost reports. Inappropriate costs may be included in quality cost reports. Many quality costs are susceptible to measurement errors. Quality cost pitfalls. Perfectionism in the numbers. Lengthy debates can occur in some companies over the need for precision in the quality cost figures. This delay may cost the company the initiative to move forward with considerable total savings. Other data pitfalls. Presentation to managers should be done in a way that discussion is on the merits of improvement proposals and not on data validity. Inclusion of non-quality costs. The management group should decide on a definition of waste. That is, will only pure product quality waste be included? Implications of reducing quality cost to zero. A quality cost presentation should recognize that it may not be realistic or economically sound to reduce quality costs to zero. reducing quality costs but increasing total company costs. It may be necessary to ensure that a reduction in quality costs will not increase total costs. Understatement of quality costs. There are many ways to understate the costs of quality. One of the most common is to deal with quality costs only in excess of some normal standard. In the prevention approach, the emphasis should be to challenge whether the standard level can be improved.